Welcome, everyone. This is MA7140 vCloud Architecture Design Strategies and Design Considerations, where we're going to try to give you a high-level overview of some deep considerations for doing the design. I myself am John Arashid. I've been with VMware for about 7 years. I am on the cloud services team. We have next to me.
This is Raman Veeramraja. I've been the cloud consulting architect in the cloud team for about 3 years.
And Pang Chen, I'm also with the cloud team. I've been at VMware for 8 years.
So, quick disclaimer, you guys have already heard the announcement. We've released our now VMware vCloud Director product. And this is basically covering some of the things that we will have in this material. It may be considered, I guess we'll say, early knowledge of some of the information that we're going to cover. So we've got, we're going to cover some of the overview of the technology. How many people here have gone to a session or a lab specifically on vCloud already? Okay, so we're not going to go through specific details on the technology. We're going to focus this more from an architecture standpoint and what you need to think about as you start putting together a vCloud architecture design. We're going to cover the components, how they work together from an architectural standpoint. We're going to look at some of the design considerations that you need to make, as well as certain cloud consumption considerations when you look at the type of end user or end customer base that you're going to be working with. By the way, we will do Q&A. We're trying to save most of the questions towards the end so we can get through all the material. If you have a question, we would request that you use the microphone over there. If not, I will go ahead and repeat the question for recording. So I'm going to turn this over to Pang for the vCloud overview.
So just really quickly, at a high level, we want to define what a vCloud is, or cloud computing in general. You hear so many definitions of cloud. Here, this is kind of the VMware definition of cloud computing, in that it's really not just a brand new way of computing, but it really is an extension of virtualization. So you see the themes here of efficiency, control, and choice. Now we've extended this onto some cloud concepts. So at the bottom layer, we've got vSphere. And we want to abstract some of the vSphere resources that you all know and love, and build upon that. And by that, we introduce new cloud abstraction layers. In this morning's session, the general session, we talked about virtual data centers. So we definitely have some new constructs to really allow you to effectively manage the underlying vSphere resources. It's also the same platform. So vCloud Director is the same platform that's being used to architect both your private cloud as well as the public cloud that are being built for consumption by and offered by service providers. So in this first iteration, we have our components of our vCloud, which is all built on vSphere, and you see some of the integration points. vCloud Director sits on top of vSphere. It really is kind of the engine and the interface with how the consumers of the resources now interact with. So the idea is really not to expose vCenter to your end consumers. It's now they're talking through the vCloud Director. And the vCloud API is part of that as well. The vCloud API is both a way to interact with the vCloud Director, but it's also our API that we're submitting to the standards body to interact with different clouds, both inter-clouds as well as from public to private. Integral to vCloud Director is a vShield manager with the vShield Edge. So now there's some level of integration where vCloud Director will call the vShield Edge devices to provide some networking services, firewall and security services. The last piece is vCenter Chargeback, which is a way to get the resources consumptions aligned with the actual kind of usage, trying to align the usage with the cost of the resources. So this is kind of at a high level, just all the pieces for our first cut of the vCloud. Over time, as we have more solutions, more products into the solution, we'll add to this. But this is kind of where we see it today. At a high level, this maps back to the cloud definition in terms of the themes of leveraging your existing investments, pooling, and zero-touch infrastructure, and so forth. I've got this here. This deck is available on VMworld.com, so I'm just going to fly through this really quickly. And last but not least, kind of visually, how do all these pieces fit in together? We're going to spend the next few minutes kind of talking about how all these pieces should be considered relatively when architecting a vCloud. And with that, I will hand it over. Sure.
So there are many different considerations we have to factor in when we're putting together a cloud. One of the biggest pieces is not listed on this chart here. It's the operational aspects, aligning the business requirements, the different goals that you need to have to support your tenants within a cloud. We're focusing on approximately 7, I believe, items here. Management and workload separation, vCloud resources, compute resources, storage, networking, scaling, and availability. I do have one other question. How many people here were involved in the beta program? Okay, sounds good. So this here gives you a little bit of a breakdown. Imagine there's a line right down the middle, just to the right of the text on the left, that kind of separates out management cluster from cluster resource groups. The management cluster includes all the components that we consider essential for running a cloud operation based on VMware technologies. So in the list that we have here, you'll see that most of the items are listed as virtual machines. In the environments that we've built out in our lab environment and with many of our customers, we've done the exact same thing. Let virtualization live on top of, let the management of the virtualization run on top of the virtualization, but we want to segment out the workloads and the consumption of resources there from what we're managing to avoid contention on the management side. So on the vCloud infrastructure, we're listing out vCenter servers, Cloud Director, cell VMs. A cell VM is basically what's used to manage a particular aspect of the cloud components. Chargeback server for identifying the cost models and doing reporting. vShield Manager, which is run as a virtual appliance to handle things similar to what we used to do in zones, but with a lot more additional features. And we'll talk a little bit more about that. We've got a number of slides we're going to focus on specifically around networking. The database VMs are another consideration. In some cases, you may need, based on how you have your environment set up, maybe some particular platforms that are physical. But we do recommend that you have the ability to put it in a virtual, and you might as well go ahead and do that to take advantage of some of the DR aspects, such as Site Recovery Manager on the management side. We also have a number of other items in here. I'm not going to run through all the details on here, but you'll see on the right side we show a number of clusters of ESX hosts that are designed specifically for running the workloads. And we're going to talk a little bit more about how you actually work at both the virtualization layer and at the cloud layer. So we've got a couple of constructs we want to run through. So when we look at doing secure multi-tenancy, there's a lot of things that have to go into play. Some things may be handled on the virtualization side. We try to do as much as we can on the networking, storage, the authentication aspects from our technology, but you may want to layer in some additional technologies to support certain specific requirements. In this case, we're giving two examples of two organizations as an example from a service provider perspective. I have another slide that'll show it from an enterprise private cloud. So think of this as the ability for two companies to work together in an infrastructure without having a conflict or having access to each other's resources. So in this particular case, we've got two separate sets of users. We have access control mechanisms. They may vary, and we'll talk a little bit about that, between how Cisco might handle something versus EMC or whatever the vendor is or whatever that customer is. We'll have provisioning policies, and we'll also have catalogs of service items. These service items could be vApps, multi-tiered or single-tiered apps that are available for an individual to pull down and deploy within a cloud environment. We also have the ability to put images up, ISO or floppy images, or we may, instead of having vApps, we may actually have operating system images that are used maybe for a dev test environment or training environments, things like that. So in this particular case, at the top layer, we're showing the two orgs. At the bottom layer, we're showing how things operate for both the vSphere level on the right-hand side, where we use port groups or DV port groups, resource pools, and data stores. Those are the key concepts that we look at the vSphere level. And on the left-hand side, these are the ways that we start partitioning the resources for the consumption model. So in this particular case, we're giving an example of 3 provider VDCs. A provider VDC is the highest layer where we carve up resources. So if we basically say we've got 100, I'll give just a rough example. So let's say we had 100 gigahertz of processing power. It may not be a lot, but just for this example. Maybe we want to have gold have a certain amount of that, silver have another, and bronze have another. It's going to be similar to how we would carve up resource pools maybe at the vSphere level, but we prefer that you do the carving up at the cloud layer so that we can actually support the SLAs based on the technology that we have behind this. So in this particular example, we may have one company accessing the gold and the silver resources, and the other customer using both the silver and the bronze. They just had a different choice for this particular type of cloud applications, and that was the choice that was made. Now, when we look at the segmentation, we also have this concept of 3 types of networks, and we're going to go into a little bit more detail. I'll do a quick run through here. External networks are items that are networks that are external to the virtualization cloud layer. So they may still be internal networks. They don't necessarily mean that it's outside of your company's firewall. In this particular case, these external networks would be external to what we're actually using to support these 2 companies. The organizational network will be dedicated to each specific company. So in this case, maybe Cisco has one org network, EMC has another org network. And then we have a third concept, which is the VApp network, where multiple VApps can communicate to each other. And unless there's a firewall or a bridge, and what you actually can, well, I won't be able to point on it here, but you'll see there's a little circle with an X through it, just below the VApp network. That's where we would actually provide some firewalling and some access to get outside of that environment.
So the key to understand here is that these are vCloud Director constructs. What we create here gets automatically created through vCenter on the back end. So in the vSphere side, you just have a large resource pool, and then vCenter, you map a provider VDC, which then maps to vCenter, and vCenter will automatically create the resource pools for you. Mm-hmm. The other thing to note here is that the organization really is the security boundary in terms of what you can and can't see. So everything in terms of your workloads and your networks are all relative to the organization.
So here's an example of multi-tenancy within an enterprise. So think of the first one from a service provider's perspective, and this from an individual enterprise company. And in this case, they may have chosen to break things down by engineering and finance. And in this particular case, they do a similar breakdown, but maybe engineering might have 2 different provider VDCs so that they can actually manage the resources within their specific organization. So maybe engineering 1 might be research and development, and engineering 2 might be QA, test, and release. That's one example that you might want to look at. So as we go through these design considerations, we're trying to break things down based on vSphere and the cloud layer. So when we look at compute resources, vSphere rules will apply. Now, when we look at the provider VDC, there's some changes that we might want to make at the lower level to support this higher cloud layer. So a provider VDC maps to a cluster of hosts managed by a vCenter server. It can be a 1-to-1 mapping or a 1-to-many mapping. We want to avoid creating nested resource pools within vCenter, because if we do that, when we get to the cloud layer, there is a possibility that VMs that aren't deployed through the cloud, using those resource pools at the lower layer, may consume resources that could affect the SLAs at the higher level. So if you create one resource pool at the vCenter layer and allow the cloud director to actually do the partitioning or the allocation of resources at its level, then you'll be able to meet the SLAs that you define. All right.
Yes. Let me just add to where John said vSphere rules still apply. What we're trying to say here is that when you're architecting a cluster and you've got vCloud Director on top of that, whatever limits and best practices you have within vSphere still apply in this case for compute resources. So if you create a cluster, you have your DRS and HA considerations there. We're just adding on top of that. And in terms of having one resource pool that are not nested, no nested resource pools below that, this is just to say that we're getting all our management on the vCloud Director on top of that. You don't want to try to fight that by going back behind the scenes in vCenter server where the vCloud Director is not aware that you're literally changing things, pulling the rug underneath from it.
We also look at creating multiple provider VDCs for segmentation in 3 different categories. There may be other categories you might want to consider, but these are the ones that we see with the customers we've been working with and the service providers we've been working with. You can do segmentation based on tiering, so resource characteristics, capacity, a quantity of resources, as well as groups. You saw that in the way that we broke down the enterprise cloud, where we had different departments to actually segment the provider VDCs. The organization VDC is a subset of a provider VDC. Organizations, as Peng said, are the security boundaries, and we use the networking, the authentication mechanisms, and all of that to actually provide a guarantee. And we do have the logging for that, so if you are going through regulatory compliance audits, you will be able to have the tools that you need to actually support your audit requirements. Now, orgs can only see a particular portion of the the provider VDC's total resources, and that's because one provider VDC may want to have multiple orgs. They may, the provider VDC will then allocate a certain amount to those orgs. They can do whatever they want with those resources that they're allocated, but they will not be able to overlap into the other orgs' resources. Now, we do that mapping of 1-to-1, so one VDC to one provider VDC, but once again, you can't have multiple orgs per provider VDC. Catalogs include standard VApp templates, as well as media, ISO or floppy images, as I said before. When we look at storage structure, we do have, as Peng said before, similar requirements as in a standard vSphere install for the rules on how you would actually do partitioning, zoning, access controls. But we do ask for an NFS partition that's available for use for transferring of certain storage items when we actually create temporary files for importing of VApps from OVF or from
Well, that applies in a case where you have multiple vCloud Director server instances, or they're also called as cells.
Yep.
So you need that for transferring.
So it's really that you have multiple cells here where you have to share the VApps in between temporarily when you move the files around. You need to have a temporary location between, so the NFS share is actually required whenever you have multiple cells, which is most of the case.
Yep. I think in most of the implementations we've done so
Correct,
far,
yeah.
they've
Most
all
of them,
used the
they are.
NFS.
And if you don't have an NFS in place, then you could probably get a NFS VM, virtual machine running,
Yep.
and then carve up NFS resources out of that.
If you want to create like a cloud in a box type of solution for a demonstration or something like that, that's one of the options that we've used. For data stores, one or more data stores are mapped to the provider VDC, and then the tiering of storage is achieved through multiple provider VDCs. Within the vCloud Director, if you provide storage presented to a particular provider VDC, all of the storage is available for deploying virtual machines or VApps. So you may have mixed tiers of storage presented, but there's no guarantee on where that VM is, or VApp is going to be deployed. So let's say you had low-end storage and high-end storage. It's possible that maybe a Microsoft Exchange server might get deployed to the low-end storage, a print server might get deployed to a high-end storage, and that is the reason why we're giving this recommendation of having multiple provider VDCs to support that multi-tiering at this stage in the 1.0 product. So we've gotten a lot of feedback on this. We do understand why you might want to have additional capability within one provider VDC to do tiered storage. That's something that we don't have in the 1.0 product.
So I think the point here is each provider VDC, you cannot assign multiple types of storages within that. So each provider VDC has to map either to a fiber or to iSCSI or NFS, some kind of tiered storage. You cannot have multiple tiered within the same provider VDC. So this is one of the reasons why you probably might have to divide them in gold and silver and all that. One of the aspects is on the storage side as well. So you want to make sure that if it is fiber, that's going to be my gold, and if it is going to be iSCSI, my silver or whatever that you want to do.
Once again, these are just examples. Afterwards, we're going to be doing a group discussion, so we're more than welcome to take some additional questions around that and give some examples. We're going to go into the networking options. I'm going to turn this over to Raman. Let's go ahead. Thank you.
So just as John mentioned earlier, so we have three kinds of networking within the vCloud environment. So the first one is the external network. The external network is kind of the interface that actually gives the vCloud access to the outside world. So if you want to have your connectivity to the internet, or if you want to have some kind of connectivity to your back to a VPN connection to your private clouds, or if you want to have some kind of IP-based connectivity. So if the service provider or your company IT is providing some kind of iSCSI-based solution, then which is outside the cloud, then you probably can use that solution as being the external network. Then underneath that, you have the organization networks. The organization networks are really the kind of a boundary within the organization where you can have multiple VApps can communicate with each other, within the same organization network. And finally, you have something called a VApp network. So which VApp network is the one that actually allows multiple VMs within the VApp to communicate with each other. So I think the bottom layer is always the VApp network. So whenever you create a virtual VApp and then it has a bunch of VMs inside, you're going to have a VApp network. So now you have to connect that to your organization network. So for instance, you have a production environment or something where you have two VApps running inside, and you need to talk to each other. Then you can have your VApp network connect to your org network directly. So which means there is no firewall, there is no NATing, there's nothing done in between them. So they can communicate with each other on the same IP subnet and all that. Now, if you have your VApp network, if you have like two VApps inside, one of them is from the DMZ, one of them is for the production or something, where you want to have some kind of NATing or firewall services done between them, then what you can do is you can actually have the VSM, which will create the edge device. Okay, so you're going to do a fencing inside, and where you can have a firewall services or you can have the NATing services. So, for instance, if you want to have a dev test environment inside, where you have two VApps, where you want to create them quickly, and they both are going to have the same configurations inside and all that. Externally, they can appear different by having the NATing services, just like in the lab manager kind of environment. Finally, go ahead.
Just want to speak just say a few things about this diagram here. This is kind of a hypothetical situation. The idea here is to give all the possible examples, and the constructs here are, this is a VApp, also known as, you might think of them as a group of related virtual machines. Maybe it's a 3-tiered app that you have that they need to talk to each other. This example is really highly fictitious because it's a 7-tiered app, but we have many options in terms of how it can connect to the network. So with the networking in vCloud Director, it's really flexible, and this may not be a real world use case, but here you see that you can have a virtual NIC connected to a network, or you can just leave it off altogether so that it's completely isolated. So the idea is really, does it need to talk outside, or if it's within, does it need to talk to other VMs? So in this example, you've got two NICs where they're connected to two different networks, or these two VMs are talking on the same network, all within the VApp. And we have integration with vShield Edge, which Raman will talk about in a few minutes, which allows you to do network translation so that you can do more security. And all this is within two levels, the VApp and then also the organization. So the example, for example, in a VApp, maybe you have your applications that only need to talk to each other and you don't want to have that visible to the outside. Or maybe you have two different VApps within the same organization that need to talk but don't need to see the outside. And finally, you have the external network, which effectively is the outside. It's either your data center line or the internet.
Thank you. So here are some of the use cases here. So the first one is like an isolated VApp, where my VApp is not connected to anywhere else. So I have completely 3 VMs inside my VApp network. So again, this is kind of a situation where you want to have a complete isolation within the VApp. The next one is more like a dev test environment, where I have 2 VApps, VApp 1 and VApp 2, and then they both have to connect to my org network, and then they both need to communicate with each other. But here it's a dev test environment where I need to have my VApp 1 and VApp 2 are both simultaneous. They're kind of like very similar to each other, and they brought up simultaneously with the same IP addresses and all that stuff. As you can see inside my VApps, they all have the same IP addresses. Again, I want this to be up and running without any conflicts because I have 2 developers running the same environment, the same IPs and all the stuff, was doing some kind of testing. So in this case, what happens is it automatically creates the fence device, the edge devices over there, and then it does the NATing service here. Okay, so you don't have to do the firewall services here. You can just do the NATing. So it does the the external IP addresses, internal IP addresses kind of thing, where they don't conflict with each other. Okay. The next one is a pre-production kind of environment, the access to the internet. So in this case, I'm actually involving all the 3 kinds of networks here that we discussed earlier. So we have a VApp network inside the VApp, and that VApp network is connected either directly or fenced. Again, directly means it connects directly without any edge device, without any firewalls, or without any NATing, right? Or it could be a fenced device between the VApp network and org network. It could be direct or fenced. From there, I want to connect it to the internet. Again, I can do the same option here. I'm connecting actually to the external network, right? My external network is the one that's mapping to the internet. So here I could do a direct or fence. Since it's kind of internet here, I want it to be secure. So where I'm going to create an edge device there and create the fencing, and here more I'm kind of using the firewall services rather than the NATing services. And also here I could allow the traffic inbound too. So if I want to allow the inbound traffic, I have some VApps inside where I'm actually some kind of DMZ or something, I'm allowing some web traffic. So you can actually go and set up the rules saying that I want to allow the inbound 443 or 80, whatever traffic that you want to allow inside. So it's actually both inbound or outbound here. Okay.
Oh, yeah. Just here, it's this, yeah, it's this, like it. There you go.
Okay, the next one is the pre-production with access to the VPN. Okay, so this is more kind of a scenario where I have a public cloud, right, connecting to a private cloud back. So in this case, I have an organization here, an org1, where they have the VApps connected in the public environment, and I have the same kind of setup, everything, either direct, or fence to the org network. From the org network, I can have a direct connection in this case, because my external network is actually not based upon connecting to the internet, right? It's actually going through a tunnel connection, SSL. So now from the external connection, it's going to go straight to my corporate through my router or something. I'm going to enable the SSL right there. Okay, this is a kind of a scenario where you can have the connection back to the VPN. And again, if you have MPLS network or something, you could do that as well here. The last one, just kind of showing you how the multi-tenancy can happen here. So I have 2 organizations here. Org1 is kind of need access to the VPN, and Org2 needs access to the internet. So the key thing here is understand that each external network could be each organization. For every different function, you need to create an external network. So for VPN, you need to have a separate external network for Org1. If Org2 needs VPN, they need to have a separate external network. Similarly, with the internet, we also are actually kind of created this as a best practice, kind of where we say every customer needs to have their own external connection, even for internet. That's because I think a lot of people would like to, especially in the service provider world, right? You need to provide the public IP addresses to them. So every customer will have public address. If you have one pool of public addresses and you provide it to a bunch of customers, it's going to be tough for you later, right, to divide them up and all that. So the best thing is always have one external network for each purpose and provide it to the organization. And some of the vSphere dependencies. So we kept talking about external networks. So I'm going to go to how external network is created and how the org networks and the VApp networks are created. So as far as there is something called network pools. So think of that as it's kind of a pool of networks that you create upfront, and that pool will be used by the org networks as well as your VApp networks. So what happens is, the vCloud director will actually go and grab one of that pool from the pool, and then assign it to the either org network or VApp network. So as soon as you create more org networks or VApp networks, it automatically pulls a network from here, from the pool, and assign it to the org network or the VApp network. So in this case, what happens is you can create 3 kinds of network pools here. So the first one is the vSphere port back. So this is a typical port back network where you have to actually go and create the port groups manually on your vSphere, and then every time you have to assign each port group that, as let's say if organization 1 needs 20 networks. So between the org networks or VApp networks, if they need 20 of them, you have to create 20 port groups. So it's actually a manual process where you have to map 1-to-1 kind of thing. And the advantage of this is you can actually have either a standard switch or a distributed switch, or you can even have a Cisco Nexus 1000 lead in this case. The next one is the VLAN back network. So in this case, what you do is you actually create a range of VLANs, right, which you have to create on your physical network as well. So if customer organization A needs 10 VLANs, then you have to go and create 10 VLANs on your physical network, and then trunk that and give it to the ESX, all your resources, across all your resources, right? And then those VLANs will be provided to the vCloud. So now what happens is, as soon as you go and create org networks or VApp networks, the VLANs will be provided. So automatically vCloud will take each VLAN and then will create a port group with that one of the VLAN IDs that you provided, and then give it to the org network or the VApp network. So this is kind of, where it takes up a lot of VLANs and stuff like that. So it's more secure, and performance-wise, it's much better as well. The last option is the VMware Cloud Network Isolation Back. So this is the VMware proprietary. If you guys are familiar with the Lab Manager, it's almost like cross-house fencing kind of thing, where instead of having the VLANs here, it's actually going to create a network IDs. So it's going to create a range of network IDs. So all you have to do is you provide how many networks you want, and then it creates network IDs and automatically takes the ID and creates a port group with that ID, and then provide it to the org network and then the VApp network. Okay, this is pretty much what we've been seeing, because it takes up less number of VLANs, so it's more applicable kind of thing. And one of the downsides on this is it needs a MAC and MAC encapsulation. It needs to have the source and the destination IP, the MAC addresses being encapsulated into the same packet. So you need to actually increase the size of your MTU to 1528, and you need to do it across all your physical network everywhere you have. Okay, and then external network is something that it doesn't get created automatically. Okay, this is something you have to create a port group manually, and then when you create your external network, you have to assign that external network to the port group. Okay, so here again you have the flexibility to create any kind of you can do a standard switch VDS, or you can do a Cisco Nexus 1000 as well. Okay. And the network security, again, I think we already went over some of these. The vShield Edge gets created. It is integrated with the vCloud Director, and it provides the services such as firewall, NATing, DHCP, and some of the port forwarding, IP masquerading, which is called PAT, as well in Cisco world. Then optional for internal connection or actually connected externally. Okay. Then the traffic segregation. Again, this is some of the the practices how you want to segregate the traffic. So the first one is we're talking there is the management cluster. Again, management cluster is where we're going to put all our management, all our VMs, right? The vCloud VMs and all that John went over. So we're going to have a separate vSwitch. Again, these are some of the best practices from the vSphere. So we're going to have a management vMotion. We're going to have a DV switch for if you have an IP storage, and you're going to have a separate DV switch for all your workloads. Okay. Then when you have the resource group is where at the bottom level, this is where you actually will be providing, this is the kind of networking where you're going to be providing to your customers. So here, one of the best practices, again, you're going to have your management, separate DV switches and all that. And you're going to have a separate DV switch for your external networks. And then a separate DV switch for your all your network pools. So this is one of the recommendations, just to make sure that to segregate the traffic between external and then the network pools for the management purposes. And the next topic is about the scalability. So the vSphere resources, again, we want to make sure all your resources can be scaled. Again, you have to go back and look at your vSphere 4.1 maximum documents, again, just to make sure how many clusters you can create, right? How many, number of VMs per cluster, number of VMs per vCenter kind of thing. And then you can scale the resources accordingly. You can actually scale your clusters, your data stores, and your switches, DV switches, all the stuff. Then VMware vCloud Director. Again, you can have multiple cells here, and you can have multiple vCenters. You can have up to 25 vCenters that can be managed by the vCloud environment. So make sure you have a kind of a load balancer. Again, the load balancer is something that you're going to use outside the vCloud environment. So the vCloud environment will be, you can have multiple cells that will be managed by your load balancer externally, so that way you don't kind of lose any connectivity or anything while one of the cells go down. Then all cells in a cluster must see the same vCenter service. You want to make sure that all all the clusters. Again, these are the same best practices we followed before. And version 1 supports vCenters. Again, we're talking only in the physical site at this point. We cannot do it across multiple sites. You cannot have vCenters in multiple sites. Then we also talked about vCenter chargeback here. We're going to go much more details into this, but chargeback servers have their own built-in load balancing mechanism. So if you have multiple chargeback servers, they can actually load balance each other. And then you're going to have chargeback data collectors. Again, we're going to start with 3 data collectors: vSphere, vCloud Director, otherwise for the VSM. As you keep increasing your cells and as you keep increasing the number of VMs managed and all that, it's a good practice to keep adding more data collectors to it accordingly. Okay.
Okay, so we've talked about architecting your cloud, and what's important now is to consider how to actually consume the resources that we've set up. So we're going to talk about resource allocation and costing models. Earlier, John talked about provider VDCs being how you aggregate your vSphere resources and provide them to your organizations for them to consume. When you carve up or subdivide the provider VDC resources, you create organization VDCs, and you have one of 3 choices that you must select. If you're not sure how the resources will be consumed, initially, what you might want to do is do the pay-as-you-go model, and that literally means we don't pre-reserve any resources until it actually is created at that time. So you see here we have a vApp, and we start stacking these up. As we start creating these vApps and using them, then they are committed and taken out of the resource that you originally allocated in the provider VDC. Now, if you have a better sense of how the organization is going to consume the resources, then we have 2 different models, what's called an allocation pool and a reservation pool. You can either give the entire amount within the organization VDC with the full guarantee, regardless of the actual usage, or you can set up a kind of a threshold where you have a guarantee and then an overcommit range. So these 2 models really don't make sense until you put the chargeback piece behind that. And if I flip the slide here, notice it really depends on how you actually get billed for what you are allocated. So earlier we saw this dark blue being the actual usage versus the light blue container in terms of the guarantees. In the reservation pool, this speaks more to an organization that wants predictable service. So I want to pay for this amount of resources regardless of how much I use. Then I get billed for the entire container, and I get a predictable bill every time. There are no surprises. Now, I may not consume everything, but I'm willing to have that level of protection just in case. Whereas another customer may want to maybe strapped a little bit for cash, and they may want to have a guarantee. Think of this as a kind of your allocation that you get, like, for example, your included minutes in a phone plan. You have this much in your basic service, but then you have the ability to exceed that, which typically you will get charged for a premium if you overcommit. So the overcommit range here is really shared, and it's available if you need to exceed that, and you get billed for your minimum plus the actual premium. So this may be a model where you have a second-tier application. You want to have a certain amount of guarantee in your services, but then you want to be able to burst beyond that. Without those 2 models, you can also just price per VM in the pay-as-you-go. And this could be, you could price by the type of VM. So here we've got the different sizes here. Maybe you want to have a larger or smaller VM, and you price accordingly. Or you could certainly meter this and price based on the actual consumption. So chargeback is kind of an optional piece within the vCloud, but it certainly helps drive the consumption, because the more that the consumers get exposure to how much the costs of the resources they are consuming really are, then they may change their behavior. Unless they have the resources to and are willing to pay for the entire container, they may want to pay a little less and kind of realign their usage.
Just want to add something here.
Yes.
So just to look at these, right, on the vSphere layer, these are actually making changes to your resource level at the what is your limit versus what is your reservation. So the pay-as-you-go is really affecting your VMs at what is your reservation, what is your limit. And then the allocation pool, think of that, it's more like a burstable kind of thing, where you're going to say, I want to have a certain level of guarantee where you set up a reservation. And then your limit could be at the maximum. Again, that is something shared. It could be burst as you need more resources. And then the last one is more like where you set up your reservation and your limit both at the same level.
So now we look at workload types. So the reason why we look at these different types of workload types is it may influence how we actually provide resources. It may influence the additional capacity we might want to have for growth. So we look at transient workload types as being any VMs that exist for a very short period of time. They could be things such as a demo environment, a training environment, where you may only need it for a day or maybe a week. We look at highly elastic. These are any VMs that fluctuate dramatically in the resource requirements. Some very obvious examples would be like e-commerce solutions during certain seasonal promotions. And we also do find that there may be a requirement for some types of Tier 1 applications. They may not be the first candidates for deploying in the cloud, but Tier 1 applications may have dramatically changing resource requirements based on the type of application that's backing it. As an example is mail servers on a Monday morning usually tend to spike. I'm not saying that's necessarily going to drive maybe storage, but it might drive elasticity on the CPU or on the memory side. We also look at scientific workloads. Hadoop has a number of things, technologies supporting basically compute clusters from high-performance computing. And so we do have some high-performance computing environments that might, if they have the right characteristics, fit into this highly elastic workload category. Then we have, of course, infrastructure, things that are going to be used that are going to be long-term. They may include some highly elastic requirements like mail servers or database servers, but they're typically things that would be stood up and stand around for the duration of the environment that you're going to be setting up within this cloud environment. Domain controllers, directory servers, file or print servers, things like that. We also have combinations of all three of these. There's a number of different reasons why we might want to look at evaluating new products. Maybe you've got Exchange 2007, you want to go to Exchange 2010, you want to try something out in parallel. This might be a good opportunity to test it out in a cloud type environment. We have other items that have come up during our engagements, other types of workloads that may not fit specifically in these three categories. So be aware that there may be certain cases where you might have certain requirements. They may be well-defined resource requirements that may just fit into what we would call maybe just like an infrastructure type of environment. So these will influence what is the full capacity that you have in the cloud. One thing that's also very important to remember is the user perspective is a very important perspective to look at when you're architecting for a cloud to support these types of workloads. But we also need to have it from the executive level. In previous times, without the cloud, we had a lot of IT groups that work on aligning with the business, but the business may not have the perfect alignment with what IT is doing. Therefore, with the cloud, we actually want to focus on getting the business drivers so that we can determine how do we create the provider pools, virtual data centers, the organizational virtual data centers to actually support those business requirements. Let's see here. There was one other thing. Actually, I was trying to remember if you had, did you get all of the slides on the other one? Yeah. Okay, just wanted to check. Okay. We did want to cover, we wanted to leave some room for some questions because we can't do a deep dive on everything around the architecture. But we wanted to point out a couple of sessions. There are a few more that have been added, and there's a master list on all the different cloud sessions. But there's a vCloud Director technical breakout session. There's a vCloud Director on vBlock. So even if you're not planning on using vBlock, there might be some perspectives that you get from that to help influence your design with other technologies. And then chargeback. There is also a session by a gentleman, first name's Dushanth, who actually has written the Evaluator's Guide for vCloud Director. I'm not quite sure if it's actually been published yet. If it hasn't, it will be shortly. And similar to Site Recovery Manager and vSphere, it walks you through from start to finish, setting up an evaluation type of environment to actually carry the workloads that you're looking at testing. There's also one other deep dive, very deep dive on the networking aspects that go into a lot more details on the security as well as deeper dive on some of the use case areas as well. So what we'd like to do right now is open it up for questions.
And before we start with questions, just a reminder, we're also available for group discussions and one-on-ones in the schedule builder, so that'll be in the alcove area, but with that, we'll take questions. So there's a mic in the center there.
Okay, we got a question?
Do you guys know of any other products that are now basically obsolete with the release of vCloud Director? I know that Lifecycle Manager is no longer available as of September 1st, which is tomorrow.
Okay. So the question was, do we know which are obsolete based on vCloud Director coming out? I don't have a specific list of the end of life for any specific products. We are incorporating a lot of different technologies into what we're doing. We do use Orchestrator with what we're doing with the cloud right now. There is still a very important aspect of how Lab Manager works with link clones. We don't provide that in vCloud Director, so there are still very good use cases in those areas. But from the standpoint of the lifecycle, I would just definitely recommend stopping by the VMware booth. They could probably provide you a little bit more information on any items on what the lifespan is for any particular product. Yep. Another question.
How is capacity managed in the cloud? Is there any capacity management components to it?
There are capacity management components to the cloud. Some of them are handled by what we're doing from the standpoint of logging, which can then be used for actually determining what the growth rate is. Chargeback actually has some of that information, but there are also other integration points that will come after the 1.0 release. So things such as Capacity IQ, Capacity Planner, and a number of other technologies. I believe at the VMware booth in the cloud area, there will be one of the product managers who can go through and give you a little bit more details on that. At this stage, I don't actually have details.
So earlier in the presentation, we had the kind of the jigsaw puzzle of the pieces in this first version of the solution. So definitely chargeback. Capacity management is something we want to consider down the road, but not initially.
These are items that are pretty straightforward. They will, items like that, capacity management, will be added in beyond what we have right now. Right now, you will need to do maybe some scripting or have your DBA do some of that stuff to help determine what the growth rate is. Although on the back end on vSphere, we already have all that capability, and from the vSphere level, all those tools for doing capacity planning, capacity management will apply as they do currently. They just aren't integrated with the vCloud Director. Yep. Next question.
Does vCloud Director require 4.1?
Does vCloud Director require 4.1? No.
It requires 4.0 U2 and
yes.
Anything above that.
So 4.0 U2 is what the minimum requirement is. We do have a recommendation, and most of our customers, we are working with 4.1 for two key areas. There are some additional cloud-specific performance enhancements, and there are some additional hooks that we've added on, including on the vSphere API and the vCloud API, to provide some additional functionality. May not necessarily be things that you need today, but there are ones that will be coming later on as we integrate some additional of our technology products.
Okay, and I have one more question. Does it make a difference as far as the type of storage that's used when we're
It does not. To give you an example, we've got some customers that are using very high-end storage, like EVA or Symmetrics, things like that. But we also have people that are using low-end storage. So if you're like an SMB, or where you might want to use NFS or iSCSI, there is an option. We've done a lab where we have an iOmega system, the IX storage system in there. We didn't get a discount on it, even though it's owned by EMC. But what we did is we wanted to look at a variety of ranges so that we could demonstrate things and show that you don't necessarily need to have high-end storage to support this.
Yeah, so vCloud Director just really works with vSphere behind the scenes. So the storage characteristics are a function of vSphere. So it's the same rules.
So everything that's
there.
supported there will apply. Yep. Okay. Any other questions? One more?
Yes, so I'm curious, we talked this morning in the keynote about how service providers will have, I forget the name of the new program, but instead of vCloud Express, it was like vCloud Data Center Services.
Oh, yes, there's vCloud Express and vCloud Data Center. Yep.
So the question I have is really around, as an enterprise, if I have my new vCloud Director infrastructure in place and I want to dynamically move that workload off to, let's just say in the example this morning, Verizon's implementation of that, how do the networking characteristics transfer? How, is that motion going to be fully supported so that my IT business units that come in, say HR, that app moves over, they have no impact into how it works?
Do you want to cover that?
So one distinction here, we saw the vApp construct, and that vApp looks the naming looks the same as the one in vSphere, but it actually is a superset. So the vApp definition within vCloud Director actually has networking characteristics in there as well. So when you transfer that vApp over to the service provider, it will inherit that.
Yeah, but there is another important aspect. You may need to set up a particular VPN type connection, MPLS, LS, or whatever. But the important thing is to understand that the naming that you have on your source site of the vSwitches, the distributed vSwitches, which map into the org, external, and vApp networks, may not be exactly the same at the provider side. So you might need to do some initial discussions to actually have that ready to go before you actually migrate it to the other location. And the migration will be a cold migration at this stage. What we're looking at is some of the technology on being able to support something more like a live migration. But there's a lot of things that actually are going to be important for us to work on before that actually happens.
Thank you.
Yep. Okay. Yes?
Can you clarify the answer you just gave him real quick? Is the IP address going to change, or is it going to stay the same?
It can stay the same, or it can change based on what type of network construct that you have and whether or not that service provider or that additional cloud has access to. So, for example, if you have a vApp network, the IP address can stay exactly the same. Nothing needs to change. But when you start using external networks where you actually have to have access, where the external IP address might change, internally, you could keep the same IP address, and on the vShield Edge component, you can provide the equivalent of a PAT-NAT translation or mapping.
So just to add to that, when you provision vApps, there's a pool of IP addresses that get assigned out. So if that is mirrored on the service provider side, then yes, you can maintain that. But if the service provider side does not have the same external networking, then that may change.
So are we stretching the VLAN, or are we doing something like overlay transport virtualization on the Nexus boxes from Cisco? I mean, what
Say
really?
that one more time. Sorry.
Well, are we really going to be stretching the VLAN? Are we going to use OTV from Nexus?
You don't have to use stretch VLANs. I'm not sure if I can explain in a really short window. I know in the labs they have it. Do you want to make an attempt on that?
You're talking about particular to your private cloud back, right? Is that what you're talking, or are you talking about?
Yeah, I've got a VM, I've got a workload, a VM, whatever we have. Let's say it's just a single VM. It's got its own IP address, exists on my private network inside my enterprise, and now I'm going to move it to Verizon.
So as an off-premise private cloud.
Yeah,
Yes.
again, that depends on, you can actually extend your VLANs over to the other side. That is totally physical still, because your external network is also available on the other side now. So you can actually, if you have your multiple VLANs that you want to allow, you can actually set up the ACLs to allow all the VLANs, and you can access them in your organization as well.
The key is if you have one subnet at one location and you don't have stretch VLANs, so there's a different subnet over there, yes, you'd have to change the IP address, and you will have to deal with the DNS effects on that side. But if it's at the vApp layer, where it's not exposed, where people aren't accessing it directly, and there's a separate gateway and that vApp network to connect to it, then in that case, that vApp can still keep the same IP address.
Are you guys going to allow us to use customization templates if we have to change the IP address like we do with SRM?
I'm sorry, which customization?
Yes.
Yeah, like we do with SRM, so that we can, whenever we move it, it'll automatically customize the OS to
we
change
have
the IP.
customization from the standpoint of the individual cloud when we're moving between different provider and org locations. If you have that, if you actually enable the security to allow for that. But we don't have all of the hybrid aspects completed at this time in the 1.0 product. That'll have to come down the road.
Okay.
Yeah.
Hey, congratulations, guys, on a great new product.
Oh, thank you.
Way to go, dude. On the kind of entry-level scaling side of things, it sounds like the hardware requirements, other than storage and a couple of clusters, doesn't seem to be too big. Would you say that the positioning of this product, the low end, has more to do with how many organizations you want to support within your IT group?
It could. I mean, basically, it's how much resources do you need to support the workloads that's going to actually drive it. So maybe if you want to start as an initial pilot and have actually a production cloud environment, you could start in a very low-cost environment. I mean, the cheapest lab that we've built was actually 2 MacBooks with 8 gigs of memory running i7 quad-core. Now, I'm not saying that you want to do that because then you're virtualizing the ESX server, but from a demonstration standpoint, that can work. If we take it a step further and we look at the number of physical servers to actually support a small proof of concept, you can do it with between 3 to 5 servers, low end. We've actually built out a lab in our office area to demonstrate this, and I think our total cost was about $5K. The list price on everything was about $20K. That included 4 terabytes of storage. It included a certain number of gigabytes of memory per each box, and so that provided a very low-end solution for us to demonstrate things with customers, especially during our beta period.
So to your point about the minimum requirements, for vCloud Director to work, you need to map to a resource pool with a cluster. So that, by definition, you need to have at least 2 hosts, and that's it. So it depends on how you want to scale that.
Thank you.
So, so looking more at kind of the business fit, then the type of organization, the type of company that would be interested in this product is one that is going to be supporting multiple diverse IT groups.
It can be, but we've also seen a very potential market space, I guess I'll say, for startups where they need to get funding from VCs and they have a limited amount that they can get to get things started off. This might be a solution that actually simplify things from the standpoint of provisioning, from the standpoint of actually starting things out, whether or not they use it as a private cloud on-premise or a private cloud off-premise. We think from the standpoint of like a startup who wants, or somebody who wants to do a certain type of demo environment, that off-premise would be a very good solution as well. But we're seeing a big uptake now on the private cloud area.
Well, the goal really is to try to speak to the customers who want to be consumer-oriented. So if you have consumers that do a lot of provisioning requests, it's not just enough to have to wait for the things to come to it. If they could just like Steve Herod said in the keynote, that if you could just pick out what you wanted and just have it there, and just have IT kind of disappear behind the scenes. That's kind of the model here. So it doesn't have to necessarily be a very complicated organization. It can be just one organization within an enterprise that just has a lot of requests. So, for example, demos or lab requests, the very transient workloads that you want to deploy and destroy, to speak, right, over and over again. So you don't want to have to go through paperwork after paperwork requesting these workloads.
So this is someone that can benefit from self-serve type of
exactly, self-service.
Yep.
Great. Thank you.
Yep. Thank you. Anything else? We could probably take one more question. Okay.
How are you guys handling the storage? Are we replicating everything? Or you had said earlier that this was a cold migration, so are we actually doing export or copy of the virtual machine in order to get it into the
In most cases, they're going to be copies at this stage. We do have some customers who are looking at basically doing replication to an alternate cloud location. The only catch is you have to have the same certain types of configurations. So, for example, if you've got an org VDC here and you want to move it to an alternate location and it has a different construct, the org name is different, things like that, there's going to be a lot more manual steps, or you're going to need to use the vCloud API. So,
okay, thanks.
Thank you. We got to finish up.
Thank you.
Next session. Thank you. Yep.